All right, so this is going to be some practice problems on momentum that are multiple choice. So very little, if any, calculus. I'm not really sure exactly what I'm getting myself into here. A ball of mass m falls vertically, hits the floor with a speed of vi and rebounds to the speed of vf. What's the magnitude of the impulse? So that's going to be how much it changes. So if it goes like this, the change is actually the addition of the two. An object moving on a horizontal frictionless surface makes a glancing collision with another object initially at rest on the surface. Is this a case which is true about the momentum of kinetic energy? The momentum is conserved. The kinetic energy may be conserved. A railroad car of mass 1,500 rolls to the right at 4 meters per second and collides with another railroad car of mass 3,000 kilograms is moved rolling to the left at 3. The cars stick together, their speed immediately after the collision is. So when they have you guys do this, if you get a problem, they're almost always going to have them going in opposite directions. So you have to put a negative in. And if you don't, if you put them both in as positive, that incorrect answer will be one of your choices. So I have 6,000 minus 9,000 is 3,000 over 4,500, which is 2/3. If I make this plus, I would have 6,000 plus 9,000, which is 15,000 divided by 4,500. And I bet that that's choice. 3 1/3. Yeah, so that would be that one if you put it in positives. 3 objects are located along an x-axis as shown above. The center of mass of the objects is, so I have 3 at 0, I have 5 at 3, I have 2 at 5, and I have 10 altogether. So I have 15 plus 10 is 25 divided by 10 is 2.5. Identical net forces acting the same length of time over 2 spherical masses, which the following describes a change in linear momentum. They should be the same because they have the same impulse. The graph above shows a variable force F that acts on an object as it moves along a straight line as a function of time. What is the change in momentum of the object from t equals 2 seconds to t equals 4 seconds? So this would be the area underneath here. And so we have a 2 times 2, we have a 4. And then a 2 times 2 divided by 2 is a 2. And so it should be a change of 6. 2 balls, A and B, have the same mass and diameter, but are made of different types of rubber. The balls are dropped from the same height above the floor. After colliding with the floor, ball A bounces higher than ball B bounces. Which of the following must be larger for ball A than if ball A bounces higher, it must have a bigger impulse because that's the change in momentum. Object A of mass m is moving east with speed v. It collides with object B of mass 2m that was initially at rest. The motion of the object before and after collision is along the same line. After the collision, object A is moving west at a speed of v over 3. What is the speed of object B immediately after collision? So if it's going west, it must be negative. So I'm going to add this to the other side, and I'm going to get 4/3 mv is equal to 2m vf. I'm going to divide by 2, and I'm going to have 2/3 v equals vf. 2 balls, A and B, have the same mass and diameter, are made from different types of rubber. That's the same problem. That's the same problem. Okay. 2 carts of equal mass are on a horizontal surface with negligible friction. Cart A is approaching cart B, which is at rest, as shown in figure above. Attached to cart B is a spring that is initially compressed. At the moment A collides with B, the spring is released and pushes cart A, as shown in figure 2 above. which defined correctly states what happens to the kinetic energy and momentum of the two-card system as a result of the collision compared to those quantities before. Momentum would be the same. We wouldn't know about kinetic energy. I don't even see where the choices are for that one. The force exerted on the ball during a collision with the wall is given as a function of time by the equation f of t equals alpha t minus beta t squared, where alpha is 400 and beta is 4,000. The ball first contacts the wall at t equals 0 and the collision lasts for 1 second. What's this? So we want to take the integral from 0 to 0.1 of ft dt. And let's put in our values. So we have from 0 to 0.1 of 400t minus 4,000t squared dt. And so this would be 200t squared, and this would be 4,000 over 3. I really only got to put in 0.1 because 0 is just going to be 0. I have 2/3, so B was our choice. Two spheres of uniform density are located distance L apart. The center mass of the two spheres is labeled P. What's the correct expression for the distance from point P to the center of the left sphere? So that's this one. So let's make this 0. So we're going to say that I have 0, M1 plus L, M2 is equal to M1, or divided by M1 plus M2 would be R. So I have L2 times M1 over D. Blocks A, B, and C are aligned along a straight line on a horizontal frictionless surface. The masses of the block are M, 2M, and 3M respectively. Block A is initially moving right at the same line of speed V as shown in figure above. Blocks B and C are initially at rest. Block A collides with and sticks to block B. The two blocks then collide and stick to block C. What is the speed of block C after the collision? So I'm going to have M times V is going to be equal to 3M times V. So that's going to give me a velocity of V over 3. And then I'm going to have 3M times V over 3 is going to be equal to 6M times V final. So it's V over 6. I think this one with that one that we're missing the maybe. Particle A and particle B, each of mass M, move along the x-axis exerting a force on each other. Potential energy of a system of two particles associated with the force is given by the equation U equals beta R squared, beta over R squared, where R is the distance between the two particles, beta is a positive constant at time t equals 0. Particle A is located at x equals 2d with initial speed v naught to the left. Particle B is at rest at the origin as shown before. At time t1, particle A is observed to be traveling with the speed of 2v v naught over third to the left. The speed and direction of the motion of the particle is okay, so I have minus m v naught. B is at rest. It's going to be equal to m times v final. And we're saying that particle A is going to the left at 2/3, so it's going to be minus m 2/3 v naught. So I'm going to add that to the other side, which is going to give me 5/3. No, it's going to give me 1/3, right? Negative 1/3. Negative 1/3 mv naught equals mvf, right? Adding positive 2/3 to negative 3/3. The m's would go away, and so it's going to be v over 3 to the left, because that's going to be negative